This is the first of 6 small videos I'll make for Chapter 4. So this is the first of what will be a total of 6 videos. They'll be shorter ones to get us through Chapter 4. Chapter 4 is looking at Newton's second law of motion. What Chapter 4 covers, and this matches your book exactly, that force causes acceleration. Force is the push or pull that causes something's movement to change. We're going to talk about a special condition of that, which is friction, to actually give it an official definition. We're going to talk about mass and weight and why, when we are using precise physics language, these two are different. We're going to give you the definition of Newton's second law of motion. We're going to talk about free fall, which will be reviewed since that's what we have done in Chapter 3. And with that in mind, we will look at non-free fall. The other thing that I've given here is the vocabulary terms that are in Chapter 4. Those are already onto a Quizlet for you. Be familiar with those, and especially the ones that kind of sort of look alike. Remember, speed and velocity aren't the same thing. Remember that mass and weight are not the same thing. So be sure that you know the difference between those as we go forward. So let's talk about the idea that force causes acceleration. All right? Remember in Newton's first law that a body in motion stays at motion, but remember that that motion is a constant velocity. And recall what our definition of acceleration is. It isn't just that something is going faster, it's that a motion changes. So your motion could either change direction or change speed and due to acceleration, that force. Let's work on that a little bit longer. I know that we were at Chapter 3 and people weren't quite together about the relationship between velocity and acceleration, so this hopefully will help you understand it better. One of the things that we realize is that acceleration is directly proportional to the net force. What this means is that as net force increases, we don't need that to look like a vector. As net force increases, acceleration will also increase. All right? Or another way to look at it, if we want to increase the acceleration on an object, we increase the force acting on it. This is you pressing down the accelerator, pressing the gas button, the gas pedal on your car harder and harder to make your car go faster and faster. The easy way to say that is that this isn't an equal sign. This is just showing you that they are related to each other. Acceleration is directly related to net force. Okay? Be careful here, because we worked hard in Chapter 3 with a special case of acceleration due to gravity. And we were supposed to remember that 10 meters per second squared. That is, though, in a unique situation that is describing only free fall. So that is us dropping the rock in the well. That is us dropping something off the top of a building. That is us watching something that we've thrown up into the air lose velocity and then start falling back down again. So free fall is the case where the only force acting is the acceleration due to gravity. All right? Is that the only acceleration that we're going to observe? No, 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 no. There's going to be a lot more accelerations that we can look at, and we'll go forward to look at that. your value of your 10 meters per squared is only used in free fall, not other acceleration situations. All right, I'm going to stop here and hopefully not have technical problems. When we come back, we will talk about friction.